Hello children, let us begin with third module of our chapter Categories of Computers and Computer Languages. When we say languages, you can quickly understand this is something about communication. Now, how do we communicate? Yes, languages. Languages help us to communicate. There are many languages known to humankind across the world: Hindi, English, Spanish, Mandarin, French, Sanskrit, etc. Have you ever wondered how to communicate with computers? And can we communicate with computers with these languages like English, French, Spanish, or even Sanskrit and Hindi? Well, the answer is these languages are not appropriate when we want to communicate with computer. And why? Because a computer needs a language that both the computer and the user can understand. Now, why do computers need a language? Since to performing every action, a computer has to be given specific instructions for specific programs. So they need different to be precise or to be able to understand precisely what a user is asking for. They need a method of communication, and that would be the language that the computer and the user can both understand. We use different programs in different computer languages to give commands to the computer. A program is a set of instructions given to the computer to perform a specific task. Software or programs are written using computer languages. The process of writing programs is called programming. The programs are written by programmers in computer languages. Just as each language in our country is different, similarly, each computer programming language is different and has got its own vocabulary called syntax and rules. Let's learn more about computer languages and the various types of software. So, first is classification of computer languages. Computer languages can be broadly classified into two categories: low-level languages and high-level languages. Low-level languages. These programming languages are designed for a particular computer architecture. That means these languages are dependent upon the hardware configuration of the computer. Programs written in these languages may not give the desired output or result if we change the hardware configuration of the computer. Therefore, these languages are often described as machine-oriented languages. Programs and applications written in a low-level language are directly executable on the computing hardware without any interpreter or translator or compiler. Machine language and assembly language are popular examples of low-level languages. Machine language. Machine language is regarded as a low-level language because it is the only language that is understood directly by the computer. Machine language makes use of the binary digits 0 and 1. It is written in the form of a string, or you can say a combination of zeros for off and ones for on. The symbol 0 stands for the absence of electric pulse, and the symbol 1 or the digit 1 stands for presence of electric pulse. Machine language programs are understood by the computer without any translations and hence are executed very fast as compared to programs written in other high-level languages. Machine language programs are machine or CPU dependent. This means that a program written for one computer may not work on another computer. Why? Because there may be a change in the hardware. So as soon as there is a change in the hardware, you need to change your program as well. It is very difficult to program in machine language. The programmer has to know the details of the hardware to write a program in this language. Also, programmer has to remember a lot of codes to write a program, which may result in programming errors because he is human. A programmer is human. He has a tendency to forget something or not to be able to recall things on time. So that may lead to errors in the program. Machine language is considered to be a first generation language. Assembly language. In assembly language, instructions are given in the form of short words called mnemonics or symbols. It requires a translator program called assembler to translate the assembly language into machine language. Assembly language is considered to be a second generation language. The symbolic programming of assembly language is easier to understand and saves a lot of time and effort of the programmer. In the assembly language, it is easier to correct errors and modify program instructions. Efficiency of execution is same as machine level language because there's a one-to-one translator between assembly language program and its corresponding machine language. One of the major disadvantages of assembly language is it is machine dependent and the programming is also very time consuming. A program written for one computer might not run on another computer with different hardware configuration. Next we have high-level languages. These are programming languages in which programs are written using English words and mathematical symbols. Programs written in high-level languages are easier to read and understand than low-level language programs. These languages are machine independent. That is, once developed, the programs can be used on any machine. High-level languages are also known as third-generation languages. Some examples of high-level languages are QBasic, Logo, C++, COBOL, Fortran, Java, etc. Let us learn a few things about these languages. COBOL. COBOL stands for Common Business Oriented Language. It is mostly suitable for businesses where there is very little processing and a huge output requirement. Fortran stands for Formula translation. It was developed by John Bakes in 1957. Fortran is a general purpose procedural imperative programming language that is especially suited for numeric and scientific computations. So, the Fortran language is mostly suitable for scientific and numerical computations where there are a lot of calculations involved. Basic. Basic stands for Beginner's All-Purpose Symbolic Instruction Code. It was developed by John G. Kemeny and Thomas E. Kurtz in 1964. It is popular among beginners because of its simple English commands and statements. Logo. Logo stands for Logic Oriented, Graphic Oriented. It was developed by Wally Furzik and Seymour Papert in 1967. It is a simple procedural programming language used in education. This language is designed for children to learn how to instruct the computer to draw pictures and do simple calculations. Most of the commands in Logo are used to draw pictures. Pascal. Pascal language was developed by Professor Nicolas Wirth and named after the great French mathematician Blaise Pascal, who had a huge contribution in inventing the computers. It was based on the methodology of structured programming. Pascal is a general purpose language used to develop application programs. The C language. C was developed between 1969 and 1973 by Dennis Ritchie at the AT&T Bell Labs. It is a general purpose programming language used to develop application programs. C++. C++ was developed by Dr. Barnes Trustrup at AT&T Bell Labs. It is an object-oriented programming language which is used for developing application programs. Java. Java was developed by James Gosling at the Sun Microsystems USA. This is an object-oriented programming language and popular because it is used widely for internet programming. C++ is the base of this language. Now we have fourth generation programming languages. The fourth generation programming languages are a group of programming languages that attempt to get closer than third generation languages to the human language, their form of thinking and conceptualization. Some features of fourth generation languages are: these are user-friendly and independent of operating system. Therefore, program made on one computer can be easily executed on another computer. They are designed to reduce the overall programming time, effort and cost. The speed of execution is very, very high. The user has to specify the required output. The rest of the work is done by the computer. Structured Query Language (SQL), Informix 4GL, ColdFusion, etc. are some of the examples of fourth generation languages. Software can be created with the help of these fourth generation languages very easily. The translators used for converting high-level language programs into corresponding machine language are known as compilers and interpreters. So there's one more important thing to note, that all the fourth generation languages use some kind of a translator. Maybe it can be a compiler or an interpreter to convert the program into machine language so the computer can understand it. Without a translator, the fourth generation languages cannot work properly. These translators are also called as language processors. Let us read about these language processors next. A program written in high-level language cannot be executed directly. It needs to be converted into machine code. For this, a translator program is required. There are two types of translators. These translators are also known as language processors. Basically, there are two broad categories of language processors. They are compiler and interpreter. However, some people also categorize an assembler as a language processor, but some do not. So let us not go into that discussion. Before we understand or we read more about these processors, we have to understand a few terms as source program and object program. Now, what are these? A program written in assembly language is called a source program or source code. A program converted into the machine language by the assembler is called object program or object code. Interpreters. Let us learn about these language processors one by one. Interpreters translate one source instruction into object code and the computer immediately executes it before jumping to the next instruction, that is line by line check. So as soon as we write a command or instruction in the languages which use the interpreter checks and jumps to the next instruction only after converting the previous instruction to the object code. If there is an error in the program, the translation and the execution stops at that point, and that error is reported for debugging. Now, what is debugging? So when we encounter an error, the interpreter gives a message that an error has been encountered, so we need to correct the error. So when we fix the error, we are debugging. So we can say finding and removing errors in a program is called debugging. This is a slow process and consumes high memory, as the interpreter is also required to execute the correct code along with reporting errors. So the interpreter has to do two tasks simultaneously. It has to check the instructions and convert them into object code, and also it has to check if the code is correct or not, and if it is incorrect or there is some mistake, it has to report the errors as well. Compilers. A compiler is a language processor which converts or translates the entire program written in a high-level language into machine language in one go. So it does not do it line by line. It takes the whole program at once and converts it to the object code. If it fails to convert the program due to any errors in the program, all the errors are reported together along with the line numbers for debugging. So when the compiler encounters any errors in the program, it reports all the errors together, not line by line. So we have the line number and we have all the errors, and one by one we can correct all the errors and we can debug them. After all errors are removed, the program can be recompiled to obtain the object program. Once the compilation process is completed, the object program can be directly executed. If the program is error-free, it gets executed. Assembler. An assembler is a computer program used for translating an assembly language program, essentially a mnemonic representation, into an object code. So when we have mnemonic representations or mnemonic words used in the program, that in the assembly language program, they are converted to object code using the assembler. Well students, that is all we have in this chapter, categories of computers and computer languages. Thank you.